Okay, I'm going to try to be patient. This is about the fourth time I've had to do this because my technology is not working very well. So let's see if I can get through. This is our study guide for the first half of Unit 5. And I apologize, I've cut off the numbers here, but hopefully you have one to look at the same time, a blank one that you can get off our calendar. Without graphing, determine whether the function represents exponential growth or exponential decay. So, how do you figure that out? You only are worried about that number right there. Anything else in the problem, it does not affect your answer. Okay? So, you need to look and decide whether that number, which we've represented with the letter B, if B is larger than 1, then we have growth, and if B is less than 1, we have decay. And 7 over 5 is larger than 1, so we have exponential growth for our first problem. Okay, second one, graph each function, be sure to show the key points. So when we did these problems, y equals 4 to the x minus 2, the first thing we did was we identified our b, which is 4, which means our parent function is y equals 4 to the x, and we had an asymptote of y equals 0 for every exponential function. Then we wrote down the key points of our parent function, which are negative 1, 0, 1, and then b, 1, and 1 over b. Okay? Then we go back to our graph and we look and see what else is in there besides our parent function, and I have a 2, or in essence I have a minus 2. And most of y'all can answer that that moves it down, which means that it is affecting the bell. No, I'm just kidding. It's affecting the y value, and I'm going to subtract 2. When it affects the y, we do the same thing. So I'm going to subtract 2 from each of my y values. My x coordinates do not change. Negative 1, 0, 1. 1/4 minus 2 is minus 1 and 3/4. 1 minus 2 is negative 1, and 4 minus 2 is 2. Um, and does my asymptote change? Okay, and I can't emphasize enough, that's really the first thing you ought to graph, because if you don't know your asymptote, you don't have any idea which way these points are going to go, or your curve is going to go. So y equals 0, this affected my y. What did I do? I subtracted 2, so 0 minus 2 is negative 2. So let's go with an asymptote, and please make sure your asymptote always needs to be dotted. So we come through, this is y equals negative 2. And then at negative 1, I have negative 1 and 3/4, which is about right here. And then at 0, I have negative 1. And at 1, I have 2. So from here, I'm going to, that's not 2. I knew there was something wrong with that. I'm looking at it going, that doesn't look like 2. Okay, so that's up here. And do your best to show me which one it approaches asymptotically and the other one goes up. Okay? Domain. The domain of every exponential function is negative infinity to infinity. Never changes. So you could go over there and put it in if you want to. Your range is your y value. So if your asymptote changed, then your range is going to change, and we have negative 2 to infinity instead of 0 to infinity. Okay? Your asymptote, or excuse me, your intercepts are where it crosses either axis, one of which is 0, negative 1. And the other one I told you in class to write down later, because I want you to tell me that you know it intersects both axes, but you need to know that we haven't done that yet, and I don't want to concentrate on that part, that problem on for this problem, that issue. Anyway, so write the word later, so you're telling me that it intersects, but you have an intercept on both axes, but we can't do that one yet. And your asymptote, of course, is y equals negative 2. Okay? Um, if your asymptote is y equals, then if your range, notice that they are tied together. So these two numbers will always be the same when you're working it. Okay, number 3. Again, first thing we do is b is equal to 1/2, y is equal to 0, and then I'm going to put my key points in my parent function, negative 1, 0, and 1. Take up a little too much room. And then I have b and 1 and 1 over b. That's why we use our fractions. Makes it easy to flip it. Okay? And then I'm going to go this way with it, so I have room. what happens? I have a 6 in there, and that 6 affects the y, and I'm going to multiply everything by 6. And then that 2 in there affects the x. It's inside, it's up with the exponent, and I always do the opposite. So I'm going to subtract 2 from each of those. So negative 1 minus 2, 0 minus 2, and 1 minus 2. And then 2 times 6 is 12. 1 times 6 and 1/2 times 6. So those are my points. Um, Asymptote, y equals 0, and 6 times 0 is 0. So this time, my asymptote is not going to change. I'm still going to have it at 0. Okay, and I plot my points. At negative 3, I have 12. 1, 2, 3, I have 12, which is, if you want to, you can put it way up there. Negative 2, I have 6, which is right here. And at negative 1, I have 3. 1, 2, 3. Okay, so you have some kind of graph that's going down. Okay, I missed that. Sorry. I tried to do a little better. And it's crossing at some point. Okay, but this is the one that's approaching the asymptote. Actually, I should probably just keep on going so you get that idea. Okay, approaching your asymptote there. All right, so domain, again, doesn't change. Negative infinity to infinity. Range, did it move? No, my asymptote didn't move. So that's 0 to infinity, and my asymptote is y equals 0. Okay, and now if I need to look at intercepts, okay, there's an intercept here, and I don't really know what it is. But on an exponential function, y'all, intercepts are so important to graphing that I want to make sure you know how to do it. So that just means y equals, okay, this is the y-intercept, so x is equal to 0. And if x is equal to 0, then it's going to be that, because 0 plus 2 is 2. And when you put that in your calculator, hopefully you do that correctly, you'll find out that it's at 3/2. So that's number 3. Let's move on. In a similar, sorry about that. All right, so if we go on to number 5 and 6, well, how funny is that? There's no 4. Sorry. When we go on to 5 and 6, y equals negative 3 to the x. Give the parent function and describe the transformation. So you're doing what you did here, but you have to tell me in words what's happening. Not tell me how to do it, but tell me in words, okay? So remember, the parent function that I've told you is y equals b to the x, but b is different. What is b in this problem? B is 3. So your parent function is y equals 3 to the x. Okay, then you go and look. There's a negative sign, and that negative sign means that my graph is going to flip. That negative is on the outside, so it affects the y, and if it affects the y, it actually flips over the x-axis. Okay, I have a 1. What does that 1 do to it? That 1 is up there with the x, so it affects the x, and it's adding or subtracting. So I'm shifting left or right, and the x always does the opposite. Okay, so the opposite would be it's -1, so I'm going to go to the right. So this shifts right 1 unit, and the 2, okay, is in there, and it's outside because it's not up with the exponent. Again, adding or subtracting, it's outside, so it affects the y, and if it does the y, it does the same thing. So +2 means it's going to be shifting it up. Okay, y equals 1/2 4x to the 1 minus 3. Again, this is the b value, so y equals 4 to the x is my parent function. Okay, and I have a 1/2, and I have a 1, and I have a 3 that I got to deal with until what it happens. So the 1/2, okay, it's important that you tell me it is outside, it affects the y, so it's a vertical, and it's less than 1, so it's not a stretch, it's what we call a compression. So it's your vertical compression factor. Then we have a 1, And that 1 is with the exponent, so it affects the x, and it does the opposite of what it looks like. So it looks like it would go to the right, but in essence it moves to the left. So this shifts left. And then I have a 3, and the 3 is outside. It does not up there with the exponent, so it affects the y. And if it affects the y, that's up or down. Y does the same things, and it's -3, so it's going to shift down. So that would be the minimum of what you would need to write for me. If there was a negative here, y'all, it's not -1/2. The negative is a separate thing that you tell me flips over the y-axis or the x-axis, and then the number is your compression or stretch. Okay, number 7. We have Margaret has 3250 in a savings account that grows 3% each year. Write an exponential function to model this savings account. Okay, we are working with this formula. Oh, not y, my bad. A of t equals a times 1 plus r to the t. Okay, this is your a right here, and this is your r, but you have to write it as a decimal, so it becomes 0.03. So when I plug that in, that's going to be a of t equals a, which is 3250. Yikes, I'm going to run out of room. 1 plus 0.03 would be 1.03 to the t. Okay, so that is a function that models the savings account. How much will she have after 6 years? A of 6 equals 3250 times 1.03 to the 6th. So put that in your calculator. Okay, it is money. So you should give me your answer to the nearest cent. So that would be $3,880.67. Again, if you have calculator questions, you can email me or come see me in the morning before school. All right. Number 8, Bob has a truck that he bought for $26,000 that loses 18%. Loses, y'all. Okay? Some people fail. This one grows. So if it grows, it's plus. However you want to think about it, whether you want to think about R as a positive and you add it, you could say R is negative, or you could know to subtract it, however you wish to do it, okay? But this is your A value, and this is R. I just know to subtract. R equals 0.18, because we've always talked about that B value is the difference between the rate and 1. Okay, so my function is going to be A of t equals 26,000 times 1 minus 0.18 is, of course, 0.82 to the t. How much will it be worth after 10 years? That's A of 10 equals 26,000.82 raised to the 10th. So when you put that in your calculator, again, this is a money problem. So to answer, you need that label of dollars. And this is going to be $3,573.65. Okay. Use a calculator to evaluate e to the 0.5. Okay, I'm going to tell you the answer. If you have trouble or need help using your calculator, then you need to come see me because everybody has a different calculator. So 1.6487. Most people just miss this because they didn't read the directions. It says 4 decimal places, so make sure you write that out and round correctly. Okay. Suppose you invest $400 at an annual interest rate of 2.2% compounded continuously. This is a very important word in that problem. That tells you that what you are using here is A equals P times E to the RT. That's our PERT formula that you use for compound interest. Okay, this is P and this is my R at 0.022. So when I put it in, I'm going to have A equals 400 times E raised to the 0.022 times, well, there's my T right there, sorry, times 3. Okay, and on a scientific calculator, more times than not, okay, you will have to use parentheses around that. Do not close it right here or you will get the wrong answer. So when you put that in your calculator, and please do so you can make sure you know how to use it, you will again come out dollars and cents, so it will be $427.29. All right, so I hope that I will do that at the end, but I'm going to extend this so we can go up. All right, keep moving on. Write the equation in logarithmic form, write the equation in exponential form. So when you do these problems, y'all, this is the definition that we've talked about, okay? And that is the log base b of y, nope, excuse me, I want to write of x equals y if and only if b to the y equals x. And that's our little kick out that we've done, this to that. Okay? So, that being said, you're either giving it to it in this form and you got to give me that form, or I give it to you in this form and you got to give me that form. But you got to be able to go back and forth between these forms. So, one of the things that I've told you about these when you're doing them, okay, let me come down here and just write it. Remember that the b is the same in both equations. B is the same, and the other thing I told you is the log is the exponent. So what is my log right here? It's y. And what is my exponent? It's y. So I'm just trying to help you to see when you put it in there. So when we go and write this one, well, there's my base. My base is the same, so I'm going to have log base 7, and my exponent is my log. So my exponent is that number over here, which leaves the last number to be here. And you check it. 7 to the third equals 343. We're good. And so it makes it a little bit easier to go from exponential to, because here's my base, so I'm doing 3 raised to that number equals that. So 3 to the negative 3 equals 1 over 27. All right, backside, evaluate the logs. Okay, so the key that we've done this, these are our what we called our White House problems. Okay, and in all my classes, I only had one that I showed the long way because the other people didn't want to know it. So if you need help with the long way, you need to come see me. But the White House problem, the log base, let's say b to the a and b to the c. So when we write these two with the same base, the answer is always c over a. That's a really general thing. Let's see if y'all can follow me. So log base 6 of 1 over 216 is the log base 6 of 6 to the negative 3. Got to remember that at 1 over is where that negative is coming from. It's not 216. If it was 216, it would be 6 to the third. Because it's 1 over, then we bring it up and make it a negative 3 instead of a positive 3. What's my exponent down here? It's a 1. So negative 3 over 1 is, of course, negative 3, and that's my answer. So when we say White House, remember, okay, it's because the answer is in the problem when we do that work. Okay? Look at this next one, log base 7 of 49. So that is log base 7 of 7 squared. And if you need to think about it, that exponent is a 1. So again, it's 2 over 1, which again, we don't write 2 over 1, we just write 2. Okay? But remembering that, because when we get to the next one here, okay, 625 is, it's whacking out at me, 5 to the 4th, and 5 is just 5, but it's 5 to the 1. And so if we continue what we've been doing, it's going to be 1 over 4 this time. So my answer is 1/4. And log base 16 of 2, again, is log 16 is 2 to the 4th. 2 is 2 to the 1st. And when I look at those exponents, because that's what the log is, it's 1 over 4. So that's my answer. Okay. What is the inverse of the log? Okay, so if you can't remember this, you do need to know that if there's no base here, it is base 10. Okay, how do we find the inverse of the log? we switch the x and the y. So if I do that, that says x equals log base 10 of y. I have to solve for y, so I put it in that exponential form, which says 10 raised to the x equals y. I'm doing it backwards. If you need to flip it, look at it this way. Log base 10 of y equals x. So 10 to the x equals y. I am okay with, if you have a question like this, y equals log whatever base to the x, that's the exponential function of the same base. Those are inverses of each other. Okay, what's this one? It's a little more involved. So if I switch the x and the y, okay, and I'm gonna flip the equations at the same time. So I'm gonna put the log over here, log base 3. I'm switching my x and y. So it looks like that. So I did two things at once. And then I'm going to say, okay, 3 to that equals that. So that says 3 to the x equals y minus 2. And I'm solving for y, so I'm going to add 2 to both sides, which is how I'm going to get, and you can write it like this, 3 to the x plus 2 equals y. That's fine. Or you can flip it. It does not matter. Okay, so now we're going to graph some logs. So to graph our logs, um, again, just like with our exponential function, the first thing we got to do is identify our base. And our base is 5. And our asymptote is not y equals anymore, it's x equals 0. And a lot of people remember that visual that we've talked about. Um, I'll stick with that. The visual log starts with an L, and that's exactly what the asymptote is doing. Okay, so this is my asymptote here. Oops, I hope it didn't move. Okay, if it moved, I'll move it. Let's go see. So my key points are with the log, because it's the inverse of the exponential, now my negative 1, 0, and 1 are on this side. B, 1, and 1 over B. Yikes. Okay, so that's my 1 over b. All right, I have a negative in here that's different from my parent function. Okay, my parent function would just be y equals log base 5 of x. So that negative is inside, and that means it affects the x. And so this is multiplying by negative 1. If I divide each of these by negative 1, then it's the same. It has the same effect. So they each become negative, and oh, don't do me this far. I'm having trouble. Okay, so I'm going to plot those. My asymptote, if I multiply it by negative 1, it still becomes 0, because 0 times negative 1. So my points are negative 1/5, negative 1, negative 1, 0, and 5, 1. So I have something that's looking like, you know, like this. And that's my log function. And if you can understand what we've done, this is affecting the x, so it flips it over the y-axis, which is what we've done. Okay, so remember, our exponential function was always negative infinity to infinity for the domain. Well, that's our range now, and it's not going to change. Okay, our domain is 0 to infinity, but this time it got flipped. Okay, it normally was 0 to infinity, but I multiplied everything by negative 1. So now this thing is negative. Well, if that's the case, we write the smaller number first. So it's negative infinity to 0. My asymptote didn't change. And my intercept is at negative 1, 0. And I don't have a y-intercept because it can't cross that vertical asymptote. Okay, next, number 20. Base is 2. Oh, don't do this to me. Again, x equals 0. And so I have, remember my negative 1, 0, and 1 are on this side. And there's my b, 1, and 1 over b. Okay, so then I'm going to go back in each of those, and I'm going to figure out what effect each additional number has on my equation. So I have a 2 in here, I have a 1, and I have a 3. So how are those going to affect my graph? So I'm going to go write my key points and I'm going to put it. That 2 is outside. It's not in the parentheses, so it affects the x. So, I mean, excuse me, it affects the y. So I'm going to multiply each thing by 2. Okay. This 1 is inside the parentheses with the x, and I do the opposite. So I'm going to add 1 to each x. And then this 3 is outside, and so it affects the y. So you can write it like this because order of operation tells us we multiply before we add. So I'm going to add 1 to each of these numbers. That gives me 1.5. 1 plus 1 is 2, and 2 plus 1 is 3. And then each of these I'm going to multiply by multiply by 2 and add 3. So negative 2 plus 3 is 1. 0 plus 3, and then 2 plus 3. And x equals is my asymptote. So whatever I did to an x, I have to do to my asymptote, and so I added 1. And so now my asymptote is x equals 1. So again, that's the first thing I want to plot because I want to have some idea. And I do hope y'all realize your graph should always resemble this. It'll either look like this or it's going to look like these. And if it doesn't, then you've done some um, you have a mistake in your calculations. So try to check that. All right, so we're plotting points. So 1.5, I'm at 1. At 2, I'm at 3. And at 3, I'm at, is that 3? 1, no, that's not 3, that's 4. So it goes here. 1, 2, 1, 2, 3. 1, 2, 3, 4, 5, and so that one's here. And so we've got this kind of thing going on, you know, something like that. Okay. Okay, so domain. Domain is my x. Did it change? It changed with my asymptote. I'm at 1 going forward, so I have 1 to infinity. My range never changes on the log. Okay, my asymptote is tied in. We already have it here, but it's also tied into that domain. Okay, because it's x equals. And my intercept is right here, and we're not going to talk about that right now, but I do have one, so just know that I can't just plug in 0 and find it, because this is the x-intercept, which means I plug in 0 there. And we don't know how to solve that yet, so just write the word later. And let's go into expanding logarithmic expressions. Having trouble talking. Okay, this is what you need to know for these two types of problems. You need to know and so I'll go back at the end and do that. All right, so the basic rules that you have for logarithmic expressions. I'm going to go write it with this. So first off, the log of m times n is equal to the log of m plus the log of n. Okay, and then I have um, the log of m divided by n is equal to the log of m minus the log of n. And then last but not least, we have, let's go with this one, the log of m to the r is equal to r times the log of m. I think I might have used n before. It doesn't matter. What matters is that you know if you have an exponent, it gets moved down front. Okay? So, in using these problems, log base 8 of c over 11, this is division. Okay? And I'm expanding it to something like this. So, when you write it, okay, log base 8 of c minus log base 8 of 11. And you do have to evaluate, can I break that up anymore? No. Can I write 11 as a power of 8? No, so I know I'm done with that. Okay? 22, a little more involved. And if you watched my video the last time, it's basically using all three of these in the same thing. So the easiest, what I find the easiest to do when you have a division problem like this, okay? Then identify each factor in the problem, which is 16, x to the third, y, and z. Okay, and you're going to break it up, and anything that's on the top is going to be positive, and anything on the bottom is going to be negative. So it's going to look like this. It's going to be the log base 4 of 16 plus log base 4 of x cubed plus log base 4 of y minus log base 4 of z. Okay, that being said, so then you got to see, am I done? I can write 16 as a power of 4, and that is log base 4 of 4 squared. I have an exponent. I can't leave that exponent. I think you all know that it goes down in front. So that would become plus log base 4, excuse me, I didn't even do it, plus 3 times log base 4 of x. And then these just carry on, plus that, and then minus that because there's nothing there. So when you write your final answer, this one is simplified. This is that White House, log base 4 of 4 squared. So that's 2 plus 3 log x plus log 4 of y minus log base 4 of z. I kind of squeezed it out, but that's what's supposed to be there. Okay, so actually, oh, poo, I don't want to do that. I'm going to rewrite that because sometimes I print it, so let's do that. Write a little small. 2 plus 3 log base 4 of x minus log plus log base 4 of y minus log base 4 of z. There we can see it all. Okay, now we're going backwards the other way. So the first thing you do is you're bringing the exponents because you can't bring them together using these two rules unless it's just a log and a log. Can't be something in front of it. So if it's addition, I'm going to bring it together. Log base 6 of x to the fourth times 5. And you can write that as log base 6 of 5x to the fourth. Okay? And the last one of this would be, all right, so it's subtraction. Oh, here's one. I do have a number here. So this number is going to become the exponent so that I have a log minus a log. So I have log of base 4 of x plus 2 minus log base 4 of x cubed. So subtraction comes together with division because that's what we do to the exponents. So I'm going to have x plus 2 and x cubed. And just to talk about it, if you had a number here, okay, as we did on the quiz and previously, that number becomes this exponent. You don't do anything to that. Just leave it as an exponent and continue with the problem. Okay, when you do this next problem, okay, of calculating the log using the change of base rule, it is important that you show me how you put that in your calculator. You just have to write the change of base rule, which I guess I should write for you. Log base b of m is log of m over log of b. Now, you can put a c here if you want to because you can change it to any base that you want. Let me see if I can move that so you can see it all. Here we go. Whoa! Um, log base c of m, log base c of m. But the b goes on the bottom, the m goes on the top. So to do this one, what you had to write on your paper to get full credit for the problem is that it is log of 48 over log of 4. And when you put that in your calculator, you should get, I didn't tell you how many places, so I don't care how many places, but you need to make sure you round correctly, however many places you carry it out to. Okay, let's do these last three problems that do with the graphing calculator. And again, make sure you write down these steps. I'm going to be demonstrating it with the Inspire. If you have something different, I should have given you some written instructions, but you want to write down those key steps on your note card so that you'll remember what to do on the test. So, on your calculator, it's going to look like this. You're going to press menu, or make sure that you go to first add list and spreadsheet. And you have to be up at this top column. And our first column is time, and that doesn't say time, so let's try that again. Time, and then I'm tabbing over to temperature. And then you skip this line. This is if you put an equation in, and we're not doing that. So we're going to put in 0, 5, 10, 15, 20, and 25. Then I'm going to go back up, and I'm going to enter 2200. and that's not 2200, 20, nope, 1700, 1275, 1000, 850, 650. So we've entered all of our problems, and I would suggest you double check. We all have the same numbers. We're going to get the exact same equation. So if yours is different, you'll be losing points on the test. So please check your numbers when you put it in there. Okay. So to get your equation, we go to Control Doc to add a new page, and we put in our data and statistics. And yes, I do know there's another way to do it, but this is the way we've been doing it consistently. On this axis, we put our time, and on this axis, we put our temperature. Okay? Every graph you have should either look like exponential growth, decay, or exponential growth. So it's looking something different. It's a good example or a good reason why you'd need to check your points. Okay, from here, menu, analyze, regression, because I'm asking you for the regression equation, and ours is exponential. So here is our equation, and you can control click to get your hand to move it. And I ask you for 3 decimal places. So this one is fine. You don't need to change that number, but this one needs to be rounded to 3 decimal places. So when you write your answer, oh, got to turn it back on. Come on. There we go. You're going to be y equals 2144.23, and I'm running out of room. Hold on, let's try that one more time. Y equals 2144.23, and then it said 0.953 to the x. So let me go check that real quick. 2144.23 and then 0.0953 to the x. Okay? So I have that. That's my regression equation. It's an equation. Got to have 2 parts. Y equals. Got to have that exponent in your variable in your exponent. And I do not have more than 3 decimal places. That one only gave it to us to 2, so you're good there. What is the percent error? How do you find that percent error? You take the actual number from this right here. So that's 2144.23 minus the actual. And your actual initial temperature is 2200 in this problem. Over 2200. And on your calculator, that's going to give you negative 0.02535. And you move it over 2 places to make it a percent. So it's going to be negative 2.5%. Okay? Last one. What is the decay rate? We take this number, 0.953. If it's bigger than 1, I'm going to subtract 1 from it. If it's less than 1, I'm going to subtract it from 1. And that's going to give me 0.047, which again, I changed to a decimal, and that is going to be 4.7%. Okay, so real quickly, I want to go back up here, and I want to highlight the formulas that you should probably have down on your card to help you remember. Okay, let's see, there's one right there. Y equals b to the x. I don't want that one, I want this one. Y equals b to the x. Here's one, exponential growth and decay. Here's one that is continual growth or decay. This is your um, going back and forth, your definition of exponent and logs. And then these are your rules for logs that you want to make sure you remember. And then, oh, here's your change of base rule. So these, you should probably have those rules down and have an example with it. And if you need this one, you got to remember where those numbers come from. All right, write down any questions you have and come see me if you need help.